Hello, ladies and gentlemen. We are on pre-calc lesson 7, inductive and deductive reasoning, logic, the contrapositive, and converse and inverse. Remember way back to your logic days in 7th grade, if you were at basis. Let's first talk about inductive reasoning. Inductive reasoning is the process of trying to find a rule. A rule meaning something that we know is true. So we can do this by gathering data, making observations, and hypothesizing. It's like being in biology and chemistry, the scientific process. Deductive reasoning is using an already known rule. What you didn't know or maybe haven't thought about is math is logic. Math is the process of thinking through something logically, and that is what we are doing in this lesson. We also have another definition, a syllogism. And this is the formal reasoning process, which is something that you perhaps learned in logic class. And what we are doing here is we are finding a conclusion based upon two premises. This is the main thing that we are going to be doing today, but we'll get there. Now, the two premises we have a major premise, and the major premise is a universal affirmative. So, for example, i.e., all men are mortal. A universal affirmative, meaning that this is a universal truth that we know. All men are mortal, okay? The major premise is the big kahuna, what we will be relating our minor premise to and everything else in our arguments to. The minor premise, then, our second premise, is identifying a member, excuse me, in that set. So in this case, we're going to our example of all men are mortal. Our set is men. So an example, Aristotle is a man. This is a true statement. Okay? Now, when we have a valid argument, a valid argument is something where the minor premise follows the major premise. Okay? A valid argument does not guarantee a true conclusion. So, this could mean I give you some falsity as my major premise, but I could still have a valid argument because my minor premise follows my major premise even though it's following a falsity. Okay? Now, let's look at this example. Okay? I want to know if I will have a valid argument or not and a valid conclusion or not. Okay? So, for example, all frogs are green. This is my major premise. Then I'm going to say Henry is a frog. This is my minor premise. And therefore, those 3 dots mean therefore, Henry is green. And I want to know, is this a valid argument or not? Well, my major premise says all frogs are green. Frogs is my set. Henry is a frog, meaning Henry is in my set, showing that my minor premise follows my major premise. This is a valid argument. Now, it is an invalid conclusion. It's an invalid conclusion because not all frogs are green. That is a falsity. But we don't care if it's an invalid statement. All frogs are green. We don't care. We care that it's a major premise and if my minor premise follows my major premise. Okay. Here's another example. I want to know, is the following argument valid? Argument valid, question mark. All normal dogs have 4 legs. That dog has 4 legs. Therefore, that dog is normal. Take a minute and see if you think, is this a valid argument or not? This is not valid. The reason it is not valid is in my major premise, my set is normal dogs. So a valid argument would have a minor premise that has something that is a normal dog. But it says that dog has 4 legs. 4 legs is not my set, it's a proponent of my set. I need that dog to be a normal dog. Therefore, this is not valid. Let's look at another example. All chickens have 3 legs. Chicken Little is a chicken. Go figure. Therefore, Chicken Little has 3 legs. Is this a valid argument? Yes, it is. It is valid. My major premise has a set of chickens. So my minor premise needs to talk about something that is a chicken. Chicken Little is in fact a chicken. Therefore, Chicken Little has 3 legs. Now, that is not a true statement. We know that Chicken Little has 5 legs. I'm just kidding. Great movie. All chickens have 3 legs. That is also not a true statement. We don't care. We only care if my minor premise follows my major premise. Only care about that. Avoid your natural instinct that wants to say it is important that all chickens do not have 3 legs. You just have to get over that. Now let's look at if-then statements. And if-then statements, the if is our hypothesis, the then is our conclusion, which this is a one-way process. You might not drive yet, but you've been on a one-way street and you only go one way. So here's an example. Rabbits are fast runners if an animal is a rabbit, then it is a fast runner. We can say that this is a valid argument because I said rabbits are fast runners. The only thing that I know in life right now is rabbits are fast runners. That's the only thing that I know. If an animal is a rabbit, so it's in my set that I then know it's a fast runner. We can relate this back to SpongeBob. If you've seen SpongeBob, there's an episode where SpongeBob is a waiter, and Squidward tells SpongeBob to forget everything except for how to be a waiter. So all that SpongeBob knows how to do is he knows how to be the world's best waiter. Well, then time comes along and one of the customers asks SpongeBob, "What is your name?" SpongeBob has a meltdown because he doesn't know his name because it doesn't have to do with being a waiter. You are SpongeBob. The only information that you know is this statement that I have told you. You only know rabbits are fast runners. That's it. So then I have to ask you something about a rabbit. If I had said, if an animal is a cheetah, then we don't know. We don't know what happens if it's a cheetah because you only know about the rabbit and that a rabbit is a fast runner. That's it. You are the waiter and you don't know your name is SpongeBob. And if you don't watch SpongeBob, I hope you are able to do so in the future. Contrapositive is a negation of an if-then statement. I did not spell that right. Negation. All right. Okay. How we do this negation is we do basically a double negative. So we do a negative if and a negative then. Okay. So let me show you an example of a contrapositive. In our last one, we had if an animal is a rabbit, then the animal is a fast runner. The contrapositive, if the animal is not a fast runner, then it is not a rabbit. Again, the only information you know is that first premise that I told you. If an animal is a rabbit, then it is a fast runner. Let me give you another example. Okay, I want to know, is this argument valid? Here's the argument. All non-athletes are vegetarians. Michael Phelps is a non-vegetarian. Therefore, Michael Phelps, I'm going to call him MP, is an athlete. We want to know, is this a valid argument? Well, the first thing I want to do is I want to look at the contrapositive. Okay, all non-athletes are vegetarian, right? This is our major premise, right? This is my minor premise, okay? So this is telling me that if they are a non-athlete, then they are vegetarian, right? We could exchange this all and this are for an if, then. If non-athlete, then vegetarian. So we can write the contrapositive, if non-vegetarian, so if carnivore, then athlete. Right? So, if non-vegetarian, then athlete, which is the contrapositive to that statement, then we say Michael Phelps is a non-veggie eater. He's a non-vegetarian. So, therefore, we can say MP is an athlete, and this is a valid argument. If you look at just this first statement, we don't know if Michael Phelps is an athlete because we only know all non-athletes are vegetarians. But this says Michael Phelps is a non-vegetarian. We have no idea what a non-vegetarian is until we look at the contrapositive. Then the contrapositive tells us that, oh, if we have a non-vegetarian, then they are an athlete. Michael Phelps is a non-vegetarian, therefore he is an athlete. That is our contrapositive. Let's move on and talk about the converse, not the shoe, versus inverse. Okay, converse is the other way, and inverse is the reverse negation. Okay, so what I mean by that, okay, is a premise. We could say if P, then Q, right? If chicken, then has 3 legs, okay? My contrapositive, I negate Q, then negate P. This means negate, meaning that here we said if non-vegetarian, right? I could say here that non-athlete is P, vegetarian is Q. So non-vegetarian is negate Q and athlete is negate P. Okay, then we can look at the converse. The converse is the other way, so Q to P, if Q, then P. And the inverse is I negate P and negate Q. It's the reverse negation because it's the reverse of the contrapositive. Okay, and we will dive a little more into these a little later. Okay. Then the next thing we have is we have what's called an if and only if statement. An if and only if, we write it as an if with a double F. And what this says is it's true in both directions, right? If P, then Q, and if Q, then P. We write it with this double arrow. So an example would be if you are cold, then you need a blanket. And in the reverse, we could say if you need a blanket, then you are cold. Now, we could look at the other examples we had. If you are a chicken, then you have 3 legs. If you have 3 legs, then you are a chicken. That gets into a little bit of a hairier situation because it's not necessarily true in both directions. If and only if is true in both directions. This will become more important when we start talking about proofs. But for now, this is all you need to know about if and only if statements. And we will leave the lesson there. That is the end of lesson 7. Again, if you had any questions during the lesson, please write them down in your notes and bring them to class the next time we talk about it.